Hello, computer science students. Welcome back. I have one more topic I want to cover with the student class before we dive into the organization class. And this topic is really talking about um, design decisions and how you create classes and what these control and organization issues show up and look like. And so this is more of a discussion than coding. We're gonna discuss what things we could fix as far as coding goes, but for now we're gonna leave it alone, so that we can run a few examples later. But as written, my student class has some dangerous design flaws. So as we left it in the last video, we have some dangerous design flaws. So what are some potential dangers and things that people could still do or misuse in our class? And the answer to that is, while we overloaded these methods to use our new system, the old methods still exist. And this leads to a discussion about well, the word legacy coding. So let's say I created a student class like this. Elon used it for years, and then we decided, well, actually, we really shouldn't let people put in wrong user IDs. Maybe, no, I don't know, an HR person or somebody finally made a mistake and wasn't tracking IDs correctly and gave a new student a bad ID, and caused the whole system to crash or something, right? So we go back and say, all right, well, we got to change this. Well, ideally, we would completely get rid of the old constructor and completely get rid of the old set ID and now force people to use our system for updating IDs, and making sure that IDs are updated correctly. However, when I do this, now the code that other people have written that depended on my old methods, setting ID with a number, creating a student with a specific number, crashes. Can't run the code anymore. So this is the kind of tricky situation that shows up in programming. You send out a class, it's used and referenced for a long time. People write a whole lot of code around it, and then we realize that there's actually a design flaw in our class, and that design flaw is that, well, being able to set IDs means that we can cause a lot of errors and problems and bugs, when we're trying to track down students and make sure each student has an individual ID. So, we're trying to make, this whole time we were working on this code for redesigning or adding functionality to do this. But right now we're overloading methods because we had to leave the old, what we call legacy content in, to be able to access, to be able to still run old code that old programs people have written. Now there are ways around this. We could, for example, leave this alone, but inside here, completely ignore the ID. So toss it away. Don't use the ID they pass in, and instead update ID. But now these two constructors are the same, so there's really not a point to them. And there's a way that you could instead call this lower constructor instead of the upper constructor from inside. But we're not going to dive into that right now. But I did want to show you can fix some of these problems. Unfortunately, what it means is someone who thought that they were actually setting an ID to something will no longer be doing that, and instead will be updating the way that you wanted them to. So now our code will run, but it's not going to behave the way we normally would expect it to. And so these are the kind of headaches and problems that show up for computer science developers. And I thought it'd be worth taking a couple minutes just to talk about why it's so important to write a class the right way and to consider future-proofing it and thinking about issues that may show up in the future and designing it in such a way that we don't run into this problem. Because the biggest bug with the class as written is that people can still overwrite it, right? People who create new students still have the power, if they use the wrong methods or whatever, to cause multiple students to have the same ID and potentially cause our whole system to crash. Although hopefully we'd also have protections against that. And so this is kind of the design flaw of the class, is that as written, we have overloaded methods where one is doing a good thing in forcing our IDs to make sure they're unique and updated in a really specific way, and the other one is still allowing us to override IDs directly and cause them to potentially be the same. So that's a problem, and it's a headache, especially when you have legacy code running based on your old class, and now you can't really update it the right way. So we could get rid of the extra constructor, the extra method, and then tell our users, well, now when you use my class or write code with my class, you have to change how all your methods are written, and we'll be cursed by everyone who's used it in the past. We could leave it as is, but then tell people they should be responsible and use other methods. We could give a warning that we're going to get rid of old constructors, so you should convert an old methods, and so you should convert your code over soon, and then eventually do that. That's called deprecating. There are alerts that go out and say, hey, this is going to be deprecated soon. You should stop using it because it's going to be gone soon. So all the things like that would be helpful to send out. And so that this is kind of a bigger picture of what does programming look like at times, and a lot of it is fixing old problems. And so I don't know that there's a perfect solution to this. It may depend on your situation and when you write your class, who it's for. But for now, I have some legacy code involving organization that was written with the old methods here, the old constructor and the old methods. So we're just going to leave them in and work through as we go. So we're going to talk a little bit more about how static is commonly used, discuss static a little more, discuss a few things a little more. And so in our next video, we'll dive into our organization class.